All right, hello. I am John. Just going to give a quick background. I'm an engineer at Defense Unicorns. Before I was working on the LeapFrog stuff, I was working on Zarf. So if you don't know, Zarf is one of our tools for making it easy to deploy Kubernetes applications into air-gapped environments. So that paired with me working on LeapFrog means that I'm hopefully going to move LeapFrog to the #1 solution for deploying AI into air-gapped solutions or air-gapped environments. And I'll let Justin introduce himself.
Yeah, thanks, John. Similar to John, I'm also a software engineer here at Defense Unicorns. Prior, I was in the Space Force and Air Force, also doing software-related things. I guess my main role here is to kind of also be a jack of all trades and get LeapFrog AI into those secure environments and make sure it works. So, speaking of that, as the title of the event kind of preluded to, we'll be talking about the challenges of deploying AI into your secure and air-gapped environments. And of course, it might work on your computer, but it's a lot more complicated when you go into places like a SCIF. So here's the agenda. We're going to talk about who and why. So basically who needs it and why they need it. We're going to talk about when AI is most useful and where it will be installed. So basically all of the installation environment constraints that we run into. We'll talk a little bit about the what. So basically in our first session, we talked about what LeapFrog AI is and what AI for national security is. And we'll dive a little bit deeper, but we're kind of hoping for an open dialogue. So please ask your questions. Otherwise, we will present this in 15 minutes and sit here silently. And then we have the how, which is the part, as I mentioned before, we're going to dive a little deeper into the stack. And then finally, we're going to talk about one instance where we responded to a real world need and kind of talk about a couple of the challenges that we faced. And I'll hand it off to John to start us off.
All right, so we're going to start off with the who and why. A lot of this was probably covered at least a little bit in the last session, but in case you didn't manage to see that or you want a little bit of a refresher, the why for AI as a whole is there's been a whole lot of recent advancements in AI, especially in the past 2 years. A lot of cool technologies are coming out, a lot of solutions, a lot of companies starting up around this AI space. One of the downsides with that, though, is a lot of these advancements are happening in fully connected areas or for people who aren't as rigorous or careful about where their data might be going. For the why for AI as a individual thing, AI can help buy a lot of things for organizations or people. Generative AI has enabled a lot of people to start saving time, either by summarizing meetings that they might have had. So you can have a meeting or a conversation like the one that we're having today and create a transcript of everything that is said. And then from that transcript, maybe you can have an AI create highlights of the most important pieces of information that was said. And instead of having to listen through a whole hour-long talk, you can get a 5-minute summary or 3-minute summary or whatever else you need. So there's a whole lot of time savings, a whole lot of creativity for problem solving too. So if you're having a little bit of a rut of where do I need to go, what do I want to think, like what am I missing that my experiences might not have like let me to quickly think about, but maybe an AI that's been trained on all sorts of different data and perspectives can give me a different idea on, as well as getting a second opinion. So sometimes there are situations where someone sees something and they think that it's what they think it is, but they're not entirely sure. So like we can see this for doctors in the field. Sometimes they'll use AI to help make a diagnosis where they'll have the AI go through first, make a prediction on whether cancer or not cancer. But you wouldn't trust that by itself, but it helps lead more conversations. It helps maybe give the doctor an idea of where to go for path forwards for diagnosis. So for the why for LeapFrog AI, as a company of defense unicorns, we have always focused around air gap first, not necessarily air gap only. So you can always use LeapFrog AI in places that are connected to the internet. But for a lot of our customers and for a lot of the people that we expect to be here, we're expecting people to have restraints on where they can host their data. So they don't necessarily want to send all of their information, data files, audio files, chat conversations to OpenAI or other third-party online resources. They want to keep that in-house to something that they can manage themselves, as well as they want to be able to deploy in a way that they don't need to have always online connections. So they don't need to always be pinging other servers for information. I think that covers the who and why of what LeapFrog AI is and what we're trying to achieve.
Yeah, so we talked about the who and why. Now we're going to talk a little bit, or we already hinted at, the when and the where. So, I mean, it may seem simple enough to kind of just go to ChatGPT or maybe even use Zoom to transcribe your meetings and summarize them. Or if you're a little bit more technical, you could even spin up a Docker container and put a Hugging Face model in it and use transformers to do some inferencing. But unfortunately, for secure and air-gapped environments, sometimes that's just not enough. And in fact, 99% of the time, that's just not enough. So that's kind of where we come in. But to go a little bit more into the when and where and describing those challenges is kind of what I'm going to talk about now. So there are times when security is going to be a priority, or maybe your operational and engineering data are classified. So that's where secure tooling comes into play, and that's included basically inside of our AI for national security stack. That tooling will handle the need for basically no internet access or hardened images or monitoring and certain cluster policies. And all these things we'll kind of dive into a little bit more later on. There's also the possibility that your environment doesn't have a 4090 or an A10 or an H100, basically GPUs that'll make things much faster and much better. So we can also bring that stack into your area where the resources are constrained. Things like a lack of VRAM or really little RAM or weak CPU means that we will need to adjust the stack or basically tune it a little bit so that it fits your needs. For example, quantization of models or different inferencing solutions, as was mentioned at the previous session. There's also the idea of high reliability and availability. So we would need to introduce things like load balancing or proper containerization. As many of you know, containerization allows us to put everything into a box that has very specific constraints so that it doesn't overreach. And we'll talk a little bit about that in the use case scenario that we're going to talk about later in this presentation, and how we overcame those challenges and how our stack basically automatically, or rather was built to be native to those challenges and to thrive in those challenging environments. Next, I'm going to hand it back off to John, and we're going to start by reintroducing the entire AI for national security stack, and then we'll dive into each part of the stack.
All right. So we're going to start off with a quick top-level overview of everything that's here. And in the next slides coming up, we'll go into a little bit more detail on the individual parts. So we're going to start off at the bottom. So first comes the UDS, which is our common baseline, which is maintained by Defense Unicorns. This makes it so that you can keep a common baseline that meet controls and requirements depending on your deployment environment, make it a little bit easier to get there. On top of UDS is the heartbeat of why we're here today, and it's LeapFrog AI. So LeapFrog AI is an open source platform for hosting generative AI models. The key takeaways of what's inside of this section is an API server that mirrors, or I think Greg said earlier, shadows, and I like that word more. It shadows the OpenAI API specification. What this buys us is it makes it easy to pick up off-the-shelf models, like Greg showed earlier with Hugging Face, and adapt them and build them into your solution quickly and reliably. This API layer will serve as a communication for your applications that are higher up on the stack, as well as the other models that you're running yourself. So I said other models that you're running yourself. So that is also part of this LeapFrog AI stack. So we call them model backends. And what that means is they are model software applications that are running. So it's just code, just like any other software application, but they're running to ingest your data and create outputs, whether it's a prediction or whether it's a chat sentence that it's outputting back to you to have a conversation with. So that also exists within the stack, and it communicates internally to go back up on the level. So we're now at the AI for national security applications. So a quick way or a high level way to think about these things are, these are applications that solve or that move towards solving specific use cases. So a lot of this might have to deal with like handling your data or ingesting or manipulating your data. So we have several capabilities that are falling under this AI for national security application stack. For example, you can have a chatbot. So we had Mattermost mentioned before. So you can have communication layers between Mattermost and your LeapFrog AI cluster. You can also have things like a summarization platform. So I made a little bit of a joke before. We can take this Zoom call that we're in right now, upload it to this application, upload the audio file, excuse me, and then transcribe it and get that as output. So all those little intersections where you're dealing with uploading data or interacting with an application will happen here at this stack. At the tippy top, we have our user interface. So all of these things are fairly simple to work with as raw code, but it's always easier to have a little bit of the interface so that everybody can use it and not just developers. So that is where we make that available for everyone to be able to use.
Thanks, John. So basically next, what we're going to do here is we're going to dive a little bit into each part of this kind of pyramid or cake diagram, whatever you want to call it. And we're going to talk about some examples of pieces that we use in each part of the diagram, as well as its description. But if you have specific questions about what actually lives in each part, we're definitely going to encourage you to ask a question or come meet us later at the happy hour to talk deeper into each part. But we just wanted to give you, let's see, wanted to show that we have some efficacy and we actually use these tools and we've actually deployed these things. So that's why we're going through it right now. But there's a lot of details and we could dive really deep really quickly. So we're going to keep it a little high level and just ask away. So this first part, or rather the foundation, Unicorn Delivery Service, is really a set of tools and abstractive layers that helps us build up to what you see, a chatbot, or whatever it may be, VS Code or something like that. So UDS, in summary, is a robust and repeatable Kubernetes bootstrapping, tooling, and installation method. It lets you deploy to many different environments, whether it's your local laptop, whether it's in the cloud, whether it's on-prem, whether it's air-gapped, or some mix of everything in between. It gives you the tooling that's required to actually keep the stack secure and to keep it maintained. So it can help you, it has Grafana. It provides you cluster policies, ingress and egress controls. And one of the tools that I'll briefly mention later even provides you an SBOM to give you an idea of what software you actually uploaded into your computer or server or whatever it may be. Everything about this part or layer is for the sake of a transparent and secure and seamless installation, as well as upgrades and patches. So everything usually is a few commands, but generally speaking, that's the whole point of this, to be declarative and to be simple to use. So earlier we talked, or actually we've talked about Zarf several times at this point, but one of the tools that is used internally by UDS is Zarf. And Zarf is kind of an example of one of our open source technologies that helps us deliver Kubernetes as well as packages into the Kubernetes clusters and nodes in an air gap. And it doesn't have to be an air gap. It can be a fully connected computer, but it makes it a lot easier because it puts everything into neat packages and abstracts away the difficulty of writing all those charts, putting all of those binaries in X, Y, and Z. And basically that's what Zarf does as part of this layer. We personally used Zarf to deploy it to a couple of locations already, which makes our AI for national security stack literally like a cake that we can deliver to you. So this layer makes it super easy. It makes it declarative. It makes it human readable. Basically, everything you can imagine is the opposite of Kubernetes or what you think of when you think of Kubernetes, if you're not too familiar with it. So that is this layer, making it easy.
All right, so I said before the LeapFrog AI part's kind of the heart of why we're here today. We're talking about deploying AI, specifically in air-gapped environments. So what makes up this LeapFrog AI component? Before I said that the LeapFrog AI has an API layer that mirrors or shadows the OpenAI specification. I'm going to dive a little bit into what that means. So OpenAI, if you don't know, is one of the most widely used API AI companies. So if you've ever used ChatGPT, that is an OpenAI application. When you talk to ChatGPT, you are using their specific model, but it's going back and forth, the communication back and forth between the web Chrome tab that you have locally and the actual API or AI that's running in a server is through the OpenAI API specification. What we get by mirroring that is the ability to talk to models that are also listening to that same specification. As a community, the AI community has kind of gotten together and realized that OpenAI is pretty ahead. So a lot of models are using that same specifications. So what that means for you as a person who wants to consume or deploy AI applications means that if you find a model that's out there, you hear about some benchmark that has really great results and you want to just see it for yourself. If you had to do all of the work of interacting with and inferencing and poking at that model yourself, that would be a good amount of head work that you have to do to get there. But because of the fact that a lot of models and a lot of people producing the models are using this API specification, you can kind of get that out of the box. We talked about before during the last session how training a large language model can take millions or hundreds of millions of dollars, depending on the scale of which you're willing to train. This makes it so that you don't have to do that yourself, and you can at least try to use the open source models that are out there. As for the open source models that are, I see Baron came on screen. Do you have something to say?
There was a question from Luke in the chat asking, does LeapFrog provide a Python API for scripting interactions with the LLM? Just want to make sure you saw that.
Oh, okay, cool. So yeah, do we have a Python API for scripting interactions? Scripting interactions, we have a Python SDK that you can use to interact directly with the models themselves. This SDK is what the models actually use. I'm going to answer your question in many parts, actually. I'm sorry, it's not going to be a super clear answer. Then I'll come back at the end and answer it distinctly. So for the AI models, for the API, the AI models are hosting their own API. They're hosting a gRPC server, and that's how our API talks to them. So yes, you could use our SDK to directly interact with the models themselves if you wanted to bypass the API. That's when I was talking before about the cake diagram and how the different layers makes it a little bit more ease of use. So as each layer you go up, it gets more user-friendly or user-intuitive. That's how that works. So yes, we have a Python library. It's called the LeapFrog SDK that you can use to directly interact with the models that are running. Hopefully that answers your question. It took a step to get there. I had to realize what you were asking. But yeah, so going to the models again. So with the models, we have a framework or a pattern that we're starting to develop around how we will wrap these models. Each model that you can see on Hugging Face has no limitation for what can be deployed onto LeapFrog. So whether it is a audio transcription model, whether it's a chat conversation model, whether it's an image recognition model, any sort of generative AI model can be run with LeapFrog with just a little bit of tweaking on when you're building the packages out for deploying it into AirGap. And we have several pre-evaluated models such as Whisper or Mistral that we've used in production-ish environments before. So if you want to go to the next slide, Justin.
Yeah. So the next part is the layer that kind of lives on top of LeapFrog AI. We kind of already alluded that to the fact that each of these layers is kind of an open architecture that could run independently. But obviously, if you're trying to deliver a mission capability, you're going to need the other layers that are on top of this. So this layer kind of can get confused with the user interface pretty often. But it's basically a little combination of both, depending on your definition. So in this case, this layer can be hosted by the mission user on-prem and on their cloud solution or whatever their environment is on top of everything else that's here. It adds that mission unique or application specific capability that goes beyond just an API that does chat completion or does embedding. So this is where you kind of add that layer we talked about in the previous session of RAG and a vector database. So basically further layers of abstraction that provide actual end capability to our users. In this layer, we've developed some of our own applications that can be used by our partners, or you can develop applications yourself. One example would be a summarization agent or an opinionated summarize agent that uses LangChain and outlines. Or you could create a haystack pipeline that performs RAG with any of our RAG databases once we release that feature to the public. Basically, it's designed to allow applications, or this layer is basically designed technically to allow anyone to build in-house or third-party or defense unicorn software engineers as well, basically applications. And that's the power of LeapFrog AI. As John mentioned earlier, OpenAI specification is something that almost all libraries follow or have an adapter to. And once you get to this layer, you can put anything on top of LeapFrog AI that you would like. And once again, this layer is completely independent of the bottom layers. So it adds to that kind of thing that I put in chat, that open modular system architecture, you know, the buzzword that acquisition officers use, except we're actually going to implement it for you. Oh, it looks like we have a question in the chat. And what we'd like to do is actually, if we see a question, we'll try to answer it as we're going. but the question is, can you use LeapFrog AI to generate code to integrate with LeapFrog AI API? Will you offer RAG with LeapFrog AI documentation to help new users get started? All right, so in the previous session, Greg talked a little bit about Continue Dev. Continue Dev has something called, okay, I have a really bad memory, but something like sources is one of the configuration options. So you can technically ask Continue Dev, which is connected to LeapFrog AI's backend, to look at LeapFrog AI, as in the code for LeapFrog AI and all of our specific stacks, and help you write that starter or skeleton code for whichever part you're working on, whether it's the interface or one of the backends. So yes, technically that capability is already there. The second part of your question for rag about our LeapFrog AI documentation, that's actually something that we have talked about internally. As we continue to build out the open source side of this stack, we want to make it easier for open source users and contributors to actually deploy and contribute to the stack. So I'm going to give you a tentative, I am not the decision maker. Yes, we will also offer that. Baron, what do you think?
Yeah. We want to make sure our documentation is there to support the community. And I don't know, I couldn't see came across as an anonymous question, but I will, in the answer, also drop a link for our current deployment guide if you're looking for some documentation on where to get started as well. But yes, documentation, very important.
Yes. And then I'll hand it off back to John.
All right, so the last part of our cake diagram here is the user interface. The complexity of this is pretty minimal, but the benefit of this is it makes it really usable. So our AI or our UI, excuse me, was designed to be user-friendly with multimodal interfaces so that you can have different experiences with the different models that you're hosting. The look and feel of this UI was designed to be similar to other online popular experiences that you might have already had. So either ChatGPT or Claude or Chat UI if you've experimented a little bit out with your AI UIs. The reason why we built this in-house instead of using an open source one was as we deployed to air-gapped environments, we needed to make sure that we were following licensing agreements. A lot of the big AI tools are either not fully open source, not fully licensed, or they're not necessarily designed to work in air-gapped environments. So the configuration for which model backends you're talking to isn't exactly there. A lot of times they kind of assume that you're going to be talking to the upstream, super popular OpenAI, and you have an API key that you're going to be using. And that doesn't work for a lot of the applications, or for all of the applications that we're trying to be able to deploy. So this user interface is something that we're designing and building out to specifically be able to use any self-hosted AI model. So even if you don't end up going with LeapFrog UI or LeapFrog AI for your hosting of your application, you could point this UI to any backend. It follows OpenAI specification, just like the LeapFrog AI does, and you can just have a full-on chat conversation or RAG conversation with your docs.
So that kind of concludes our slightly more deep dive into each part of this cake diagram. Before we move on to the next chart, just trying to see if there are any questions that anyone has. And if not, we can move on to the case study. But a lot of the things that we talked about today are really around the expertise that we can provide in customizing your solution. And even if we don't need to customize your solution and you're just looking for the technology, we also have that. So yeah, but the next chart, we're going to talk about where we actually installed this in a classified environment and what we did for the customer to help inform them of what would be best for their particular use case. So I don't think I see any questions.
Yeah, I haven't seen any other questions. I think you guys were hitting them all as they came up.
Great. All right. So I'm going to quickly go over basically responding to a very urgent need that one of our classified mission users had. And I'm just going to run through the successes and then talk about some of the challenges that we faced that we're allowed to talk about outside of that environment. So we had a classified mission user who needed to deploy something to SIPRNet fast. We basically got the request, and we had about 1.5 months to really execute. And this was in between holidays as well. So it was a little bit difficult, but it was in response to real world events. Basically, the customer in general wanted us to do what you basically saw earlier in a demo, turn audio to text, and then process it into some sort of valuable insight, a sitrep. So some of the successes that we had. We were able to pass cybersecurity scans. We sent over our source code and the binaries that we would require, as well as some of the dependencies that we require at the OS level to our user. And they were able to look through our code and give us the green light to come and install it. After that, we were successfully able to install the entire stack without internet onto their SIPRnet virtual machine. And unfortunately, the customer didn't have access to GPUs. They only had a limited set of CPUs as well as limited RAM, and we were able to run on that. It was a bit slower, but it did complete the mission that was asked. And also, it was exposed to all of their users on SIPRnet. And then, of course, this install moment, was also kind of a forged by fire learning moment, despite the fact that many of us have some experience in classified environments and some of us are very knowledgeable in Kubernetes. There are still things that we discovered as we were in the classified environment that we had to overcome. And that's kind of what I'm going to talk about next, is the challenges and things, or the design process, and then the challenges that we had to overcome. So earlier I had mentioned that we could do CPU only. So they gave us our basically problem statement. They said we need audio, we need text, and then we need summarization. So that's when we decided to go off and run some benchmarks for them so that we knew if we needed the data that we could back our decision making for the inferencing engine as well as the model. So as many of you know, one of the popular models for audio to text is Whisper. And of course, Whisper comes in many different flavors. There are different sizes, and then there are also the inferencing engines that actually interact with that particular model. Throughout that process, we created basically a script that automated the metrics and then put it inside of a spreadsheet. In this case, we decided to go with Faster Whisper. Faster Whisper in particular is good with CPU and GPU, and it provides much quicker inferencing than Whisper CPP alone. It also allows us to adapt between GPU and CPU since it has both readily enabled. So we created a new backend. That was that layer that we talked about earlier, basically the LeapFrog AI layer in that gray box. There was the models part. So we create a backend that interacts with our API that interacts with the front end. So after doing all those evaluations, we made our choice. And we basically did a bunch of testing locally as well as on cloud instances so that we were sure it worked on different locations. After that, we thought we had done all the testing that we had needed when it comes to deploying. But obviously, whenever there's a demo, things mess up the day of. So when we walked in, we were pretty confident we could install this. But for example, one of the well, actually, I'm going to step back a bit because there was one part that I missed about the designing part. There was also the actual LLM that did the summarization. So as you know, large language models are very large, and the larger they are, the longer it takes to inference them, especially if you have, for example, a CPU. And specifically in this environment, the CPU was on a virtual machine. So all of those are kind of time shared, which makes it even slower. But what we had to look into was the quality of the summarization and the right model to actually do the summarizing. So we had to look into quantization. This might have been mentioned earlier, but I don't think so in particular. But basically, quantization is trying to pack everything into a smaller package, if I had to be very high level, and then still get somewhat of a similar result. So you could kind of think of it like as in averaging a bunch of things into smaller pieces. And the average of those pieces still represents the greater overall average. So that's basically what we had to do. We also ran some tests with different large language models and ultimately chose one. And we used that model, the quantized version of the model, to create the summarizations. After that, we created the front end, which was actually a result of one of our other engineers during Dash Days, and we built on top of that, Dash Days being kind of like a hackathon. So we built on top of that, and we gave it a prompt that would actually spit out what looks like a sit rep, which you saw before, which is like the bluff, the notes, and then the action items. So that was the design process. Back to the challenges. Basically, at the challenge part, when we walked in, the virtual machine was pretty well set up, honestly, by the IT team and the Linux team that was there. But there were certain things that both of us didn't understand about each other's specialties that would run us into trouble. One of the many examples is dissystig requirements give you a very specific way that you need to partition your actual system. And of course, as many of you know, even in a containerized environment, there are different areas where you're going to store volumes or different areas where you're going to store files. On your local system, for example, if you're using Hugging Face transformers and you download a model, it's going to cache it inside of a Hugging Face folder, either in temp or somewhere like that. But in our specific case, because everything is containerized, we can not only constrain what resources that container gets, but it also constrains where everything is stored. Unfortunately for us, because we were using something that stores a lot of things inside of the Docker area of the partition, but the engineers who created the virtual machine didn't know, we ran into disk pressure, which is becoming a pretty common problem that we've actually started to mitigate and understand much better now because of that experience. So we had to increase that partition's size because we were storing things inside of var/lib/docker, for example. And that was one of the things that you don't discover on your personal machine or when you're just deploying something straight into your host environment, like just straight Hugging Face. So that's one of the challenges we faced. And as I mentioned earlier, the constrained resources were kind of inhibiting or making everything a little bit slower. So even with a good amount of RAM and a relatively decent Intel CPU, you're going to run transcriptions a little bit slowly. However, because we were using Faster Whisper and because we picked a specific model class, we were able to get the transcription time down for a 3-hour video down to basically 20 minutes. So basically, imagine you're a CGO and you had to, and this is actually exactly what happened. You're a CGO and you have to listen to a whole meeting, write down all the notes, and then summarize them. That was basically the job of 3 CGOs full time at this particular customer location. And sorry if CGO doesn't make sense. Basically, it's an officer. You can think of it like a young engineer like myself. And that's all they did all day. So we basically cut that out, made it easier for them, installed everything. And they were actually pretty happy with the results, especially the transcription part. And we overcame all those challenges in this particular use case. In terms of like future leaning ideas, this particular customer did talk about potentially getting GPUs to make this faster, and we've tested that as well here to make sure that things are actually faster. GPUs would also increase the quality, but because we're able to unquantize the models, as in not use smaller models, or basically models that have been scrunched down. But I know I spoke a lot of words and I spit a lot of things out there. So if you have any questions, feel free to put them in the Q&A section or put them in the chat. And yeah, that's kind of the case study.
And I just want to say, shout out to Justin and Gato were the 2 guys who went on site to manage this, but the whole team working very quickly. And, as Justin was talking through that, you could hear these deployments are not, easy. And it's the case of it works on my machine when you're going into a new environment with all those resource constraints. And there is a lot of consideration of what does that environment look like? What are the models I'm going to be able to run? And, what does the mission call for too, in terms of computational time? Could I wait longer for this, and use a larger model, but it's going to run slower, or do I need to use a quantized model? There's a lot of factors and all that go into there to making sure we're delivering what the mission really needs. And yeah, I saw a comment. What do the CGOs do once they're no longer necessary? I don't know. As a former officer, go make other PowerPoint slides would be my joke answer. But there's plenty more stuff to do. It is freeing up where there's these type of manual tasks that you can automate or leverage AI to free up people, like that gives them the bandwidth to then go focus on things that need that human thought and need that capability. PowerPoint, yeah, when AI takes over making all the PowerPoints, then I don't know what the CGOs will do. And I saw there were some questions, and I know, John, you've been in here sort of chatting about it. Do you know any more details, or can you talk to the models you guys used on the Mistral side? No? Okay.
I was going to let John take it since he was already chatting, but yeah, John, you can go.
Oh, sorry. I actually did not know if we could.
Oh, okay. We'll leave that detail out. So cool.
Oh, you were talking about specifically for this use case.
Yes.
As in the customers. Okay.
Mistral is a great model. We love it for many different use cases. Maybe this one.
Yeah.
And
I think.
Yeah.
Yeah.
We'll leave it at that. It was yeah.
I think, I mean, in a later talk, Jared's going to talk about evaluating models. There are many different ways to evaluate models, and he'll dive into that. But if you're talking about open source evaluation, you can always go on Hugging Face's OpenLLM. You can go to Chatbot Arena, whatever you choose, just to see the quality of what the outputs are when you provide an input or a particular input to a particular model. But for every specific use case, there's going to possibly be a specific model, and we'll make sure to choose the right one with actual data.
Right one could be a relative thing too. So we talked about size constraints for different models, which is very important because that's a hard line, yes or no, whether you can run it or not. But there's also constraints on maybe time. So if you're willing to wait 5-10 minutes for a result, you can use a much larger model and just have it go slower. But maybe you're in a situation where you need a result instantly, like within seconds or nanoseconds. And you can always achieve that, but there is a buy-off of if you're getting a result that quickly, you're not going to get as detailed or as accurate as the result. So there's all sorts of different things to start weighing scales against when you're comparing models and evaluating, which is perfect for your use case.
Yep, seeing a few other comments coming in. Let's see, whenever you pick a model, plan on a new model coming out in a month that may be better. Absolutely, yeah, things are moving so fast. It's hard to keep up, and it does feel like there's a new model coming out every couple of days or something. So that's one thing is, as a team, we stay on top of what is the latest, in state of the art. And as John mentioned, or I think Justin mentioned, the next talk with Jared will be talking about how we're doing evaluation, so we can say this new model, is it better, or how much better is it than what we were using yesterday, and so we can arm ourselves with more tools.
Yeah, and actually, just to expand on John's point about time, when I first experimented with some models, I was using a very bad laptop, only 6 gigs of RAM and 13th generation i7, and just like something a little under 1 billion parameters to inference. Took like a minute and a half, I want to say. It was like a very short input, very short output. So if you're willing to wait, it's okay. Obviously, there are other ways to make it faster. I was just using pure PyTorch. But yeah, if you have a use case and you need advice, we'll obviously help you tailor that particular model and set of solutions for your use case.
Well,